on the mouse bottom, always have that. And when I'm sleeping, my hands fall down on the mouse, then like this. Then I'm clicking, then it's interrupt the auto reach. But I'm not supposed to fall asleep when I'm reading all this. But that's because normally I'm very sleepy in the morning, because sometimes I sleep very late, like 1 or 2 a.m. in the night. And I'm getting up before 9 a.m. so I never sleep enough. But I talk about that many times. Just getting up in the morning. I have nothing to get up to in the morning, but just getting up anywhere. And I have this debt, $1,100 I have to pay every month. I did that 7 years. Yes, next year, February, in half a year, 6.5 years, I pay like more than $1,000 every month. So my life really been really crazy the last 6-7 years, because I have this debt. I cannot really do anything. I cannot travel. I cannot buy stuff I like. So I've been home alone a lot. And I don't have the money to buy a new computer. This computer is 4 years old. So I like to play computer games, because I have done that 20 years and I'm spending a lot of time in my apartment alone. So that's nice. I could play some computer game, but now I'm close to age 60. I have to get out in the real world. I have to travel a bit before I'm getting real old. I have to get out and meet some people and eat some nice food. Get a driver license. I don't have a driver license to a car. Yes, I have to get an electric scooter, I think you call it. Not electric scooter. Yes, I don't know how to translate it, but a lot of stuff I need to buy to do what I like, but I don't have the money. But I can do this summer. And I'm still trying to lose a lot of weight. I'm still more than 105 kilos. I have to get below like 90 kilos. So we just do this while I'm losing my weight. I'm just laying here, losing some kilos weight, drinking lemonade and read this PDF the whole summer. But now we have to read page by page.
The Power ISA version 3.0 allows 64 bits for an effective address, mapped to a segmented address with between 65 and 78 bits allowed, for virtual memory, and, for any given processor, up to 60 bits for physical memory. 28. The Oracle SPARC Architecture 2015 allows 64 bits for virtual memory and, for any given processor, between 40 and 56 bits for physical memory. 29. The ARM AArch64 Virtual Memory System Architecture allows 48 bits for virtual memory and, for any given processor, from 32 to 48 bits for physical memory. 30. The December Alpha specification requires minimum of 43 bits of virtual memory address space, 8 TB, to be supported, and hardware need to check and trap if the remaining unsupported bits are 0, to support compatibility on future processors. Alpha 21064 supported 43 bits of virtual memory address space, 8 TB, and 34 bits of physical memory address space, 16 GB. Alpha 21164 supported 43 bits of virtual memory address space, 8 TB, and 40 bits of physical memory address space, 1 TB. Alpha 21264 supported user-configurable 43 or 48 bits of virtual memory address space, 8 TB or 256 TB, and 44 bits of physical memory address space, 16 TB, 64-bit applications. 32-bit vs 64-bit. A change from a 32-bit to a 64-bit architecture is a fundamental alteration, as most operating systems must be extensively modified to take advantage of the new architecture, because that software has to manage the actual memory addressing hardware. 31. Other software must also be ported to use the new abilities. Older 32-bit software may be supported either by virtue of the 64-bit instruction set being a superset of the 32-byte instruction set, so that processors that support the 64-bit instruction set can also run code for the 32-byte instruction set, or through software emulation, or by the actual implementation of a 32-bit processor core within the 64-bit processor, as with some Itanium processors from Intel, which included an IA32 processor core to run 32-bit x86 applications. The operating systems for those 64-bit architectures generally support both 32-bit and 64-bit applications. 32. One significant exception to this is the IBM AS/400 software, for which is compiled into a virtual instruction set architecture, ISA, called Technology Independent Machine Interface, TIMI. TIMI code isn't translated to native machine code by low-level software before being executed. The translation software is all that must be rewritten to move the full OS and all software to a new platform, as when IBM transitioned the native instruction set for AS/400 from the older 32/48-bit IMPI to the newer 64-bit PowerPCAS, codenamed Amazon. The IMPI instruction set was quite different from even 32-bit PowerPC, so this transition was even bigger than moving a given instruction set from 32 to 64 bits. On 64-bit hardware with x86-64 architecture, AMD 64, most 32-bit operating systems and applications can run with no compatibility issues. While the larger address space of 64-bit architectures makes working with large data sets in applications such as digital video, scientific computing, and large databases easier, there has been considerable debate on whether they or their 32-bit compatibility modes will be faster than comparably priced 32-bit systems for other tasks. A compiled Java program can run on a 32 or 64-bit Java virtual machine with no modification. The lengths and precision of all the built-in types, such as char, short, int, long, float, and double, and the types that can be used as array indices, are specified by the standard and are not dependent on the.
Yes, we have to read page by page because I made this mistake. I was clicking the mouse because I was to fall asleep.
Underlying architecture. Java programs that run on a 64-bit Java virtual machine have access to a larger address space. 33. Speed is not the only factor to consider in comparing 32-bit and 64-bit processors. Applications such as multitasking, stress testing, and clustering for high-performance computing, HPC, may be more suited to a 64-bit architecture when deployed appropriately. For this reason, 64-bit clusters have been widely deployed in large organizations, such as IBM, HP, and Microsoft. Summary: a 64-bit processor performs best with 64-bit software. A 64-bit processor may have backward compatibility, allowing it to run 32-bit application software for the 32-bit version of its instruction set, and may also support running 32-bit operating systems for the 32-bit version of its instruction set. A 32-bit processor is incompatible with 64-bit software. Pros and cons. A common misconception is that 64-bit architectures are no better than 32-bit architectures unless the computer has more than 4 GB of random access memory. 34. This is not entirely true. Some operating systems and certain hardware configurations limit the physical memory space to 3 GB on IA32 systems, due to much of the 3-4 GB region being reserved for hardware addressing. See 3 GB barrier. 64-bit architectures can address far more than 4 GB. However, IA32 processors from the Pentium Pro on would allow a 36-bit physical memory address space, using physical address extension, PAE, which gives a 64 GB physical address range, of which up to 62 GB may be used by main memory. Operating systems that support PAE may not be limited to 4 GB of physical memory, even on IA32 processors. However, drivers and other kernel mode software, more so older versions, may be incompatible with PAE. This has been cited as the reason for 32-bit versions of Microsoft Windows being limited to 4 GB of physical RAM. 35. Although the validity of this explanation has been disputed. 36. Some operating systems reserve portions of process address space for OS use, effectively reducing the total address space available for mapping memory for user programs. For instance, 32-bit Windows reserves 1 or 2 GB, depending on the settings, of the total address space for the kernel, which leaves only 3 or 2 GB, respectively, of the address space available for user mode. This limit is much higher on 64-bit operating systems. Memory-mapped files are becoming more difficult to implement in 32-bit architectures as files of over 4 GB become more common. Such large files cannot be memory-mapped easily to 32-bit architectures, as only part of the file can be mapped into the address space at a time, and to access such a file by memory mapping, the parts mapped must be swapped into and out of the address space as needed. This is a problem, as memory mapping, if properly implemented by the OS, is one of the most efficient disk-to-memory methods. Some 64-bit programs, such as encoders, decoders and encryption software, can benefit greatly from 64-bit registers, while the performance of other programs, such as 3D graphics-oriented ones, remains unaffected when switching from a 32-bit to a 64-bit environment. Some 64-bit architectures, such as x86-64 and AArch64, support more general-purpose registers than their 32-bit counterparts, although this is not due specifically to the word length. This leads to a significant speed increase for tight loops since the processor does not have to fetch data from the cache or main memory if the data can fit in the available registers.
Yes, next page.
Example in C int A, B, C, D, E. 4, A equals 0, A and LT100, A plus plus. B equals A. C equals B. D equals C. E equals D. This code first creates 5 values, A, B, C, D and E, and then puts them in a loop. During the loop, this code changes the value of B to the value of A, the value of C to the value of B, the value of D to the value of C and the value of E to the value of D. This has the same effect as changing all the values to A. If a processor can keep only 2 or 3 values or variables in registers, it would need to move some values between memory and registers to be able to process variables D and E also. This is a process that takes many CPU cycles. A processor that can hold all values and variables in registers can loop through them with no need to move data between registers and memory for each iteration. This behavior can easily be compared with virtual memory, although any effects are contingent on the compiler. The main disadvantage of 64-bit architectures is that, Relative to 32-bit architectures, the same data occupies more space in memory, due to longer pointers and possibly other types, and alignment padding. This increases the memory requirements of a given process and can have implications for efficient processor cache use. Maintaining a partial 32-bit model is one way to handle this, and is in general reasonably effective. For example, the Z/OS operating system takes this approach, requiring program code to reside in 31-bit address spaces. The high-order bit is not used in address calculation on the underlying hardware platform, while data objects can optionally reside in 64-bit regions. Not all such applications require a large address space or manipulate 64-bit data items, so these applications do not benefit from these features. Software availability. x86-based 64-bit systems sometimes lack equivalents of software that is written for 32-bit architectures. The most severe problem in Microsoft Windows is incompatible device drivers for obsolete hardware. Most 32-bit application software can run on a 64-bit operating system in a compatibility mode, also termed an emulation mode. For example, Microsoft WoW64 technology for IA64 and AMD64. The 64-bit Windows native mode, 37, driver environment runs atop 64-bit NTDLL.dll, which cannot call 32-bit Win32 subsystem code, often devices whose actual hardware function is emulated in user mode software, like Win printers. Because 64-bit drivers for most devices were unavailable until early 2007, Vista x64, using a 64-bit version of Windows was considered a challenge. However, the trend has since moved toward 64-bit computing, more so as memory prices dropped and the use of more than 4 GB of RAM increased. Most manufacturers started to provide both 32-bit and 64-bit drivers for new devices, so unavailability of 64-bit drivers ceased to be a problem. 64-bit drivers were not provided for many older devices, which could consequently not be used in 64-bit systems. Driver compatibility was less of a problem with open-source drivers, as 32-bit ones could be modified for 64-bit use. Support for hardware made before early 2007 was problematic for open-source platforms, due to the relatively small number of users. 64-bit versions of Windows cannot run 16-bit software. However, most 32-bit applications will work well. 64-bit users are forced to install a virtual machine of a 16 or 32-bit operating system to run 16-bit applications. 38. Mac OS X 10.4 Tiger and Mac OS X 10.5 Leopard had only a 32-bit kernel, but they can run 64-bit ISA mode code on 64-bit processors. Mac OS X 10.6 Snow Leopard had both 32 and 64-bit kernels and, on most Macs, used the 32-bit kernel even on 64-bit processors. This allowed those Macs to support 64-bit processors while still supporting 32-bit device drivers, although not 64-bit drivers and performance advantages that can come with them. Mac OS X 10.7 Lion ran with a 64-bit kernel on more Macs, and OS X 10.8 Mountain Lion and later Mac OS releases only have a 64-bit kernel. On systems with 64-bit processors, both the 32 and 64-bit Mac OS kernels can run 32-bit user mode code, and all versions of Mac OS up to Mac OS Mojave 10.14 include 32-bit versions of libraries that 32-bit applications would use, so 32-bit user mode software for Mac OS will run on those systems. The 32-bit versions of libraries have been removed by Apple in macOS Catalina 10.15. Linux and most other Unix-like operating systems, and the C and C++ toolchains for them, have supported 64-bit processors for many years. Many applications and libraries for those platforms are open source software, written in C and C++.